You're all aware of this statistic, I'm sure, that we spend 90% of our time indoors, one way or another. I'm going to start with just going through the things that are dealt with in sick building syndrome. Now, this isn't comprehensive, it's just some of the headlines, because there are many factors. One of the reasons why it's so difficult to pin it down is that there are so many factors that there's always something that you can add, and there's probably sometimes something you'd be as well subtracting. And I'm going to tell you a little story to start off with. It goes from 1974, when I first came across this. I was doing a lot of work in Germany at the time. My second language is German, and I've worked with a lot of German architects, and was getting involved in a lot of things in Austria and Switzerland, where this whole building biology movement is very strong, and where they were already doing, looking at issues to do with indoor climate. And the story from Hubert Palm was that in '71, the State Laboratory for the Control and Inspection of Foodstuffs in Geneva was given a new state-of-the-art building with all the latest in sophisticated technical installations. After occupation, all the food tests started to register excessive toxicity levels. When control measures were made back in the previous building, toxicity levels were found to be back to normal. Ultimately, it was discovered that the high-tech materials in the new building were the cause of the high toxicity levels in the foodstuffs, and that it was occurring after only a short storage time in the building. The emissions were found to be coming from paints, plastic materials, varnishes, flooring and furniture. And they were not just poisoning the foodstuffs, but also the room air. That's some time ago, 1971, that's 40 years ago. Now, I've made an assessment through various studies between then and now, and if we look at 1971, and we look at the number of materials, and then the number of, there's another study done in '83, and I've done a projection from that, then the number of toxic materials has increased in my working lifetime as an architect exponentially. Now, the World Health Organization considers that 25 to 30% of the total disease burden in developed countries can be attributed to environmental factors. That's a hell of a lot. You know, people think of illness coming from all sorts of other things, viruses and so on, but environmental factors. And remember back to the 90% indoors. On the basis of currently available information, the contribution of bad indoor air quality to the total burden of disease cannot be quantified with a high degree of certainty. And that's our problem as specifying architects. Nobody's done the research. Therefore, the precautionary approach is the only approach. Exposure to single compounds does not reflect the real health risks. The focus should be on combined exposure to chemical mixtures, i.e. cocktail effect. This is not me speaking, this is the EU. Projects combining epidemiological, chemical and biological studies could provide the knowledge needed to assess the risk and evaluate the impact of indoor air pollutants on human health. Isn't it astonishing it hasn't been done? Now you'll see that in terms of bacteria and virus, the two ends of the difficulty of the problem. In terms of mold and fungi, if you keep the room below 50% RH, they will not thrive. They'll always be there, but they won't thrive, which means the dust mites will hibernate, and it means the mold will stay dormant, and it won't be active. In terms of allergy and asthma, what is interesting is that the tendency is when it gets more dry, then the reaction is worse. So if you get this fluctuation between low humidity and high humidity, which quite often happens with fan power, they click in and click out at certain RH triggers, you get this vacillation and you don't get this moisture buffering. It's done technically rather than through the fabric of the building. This is one of the problems I have when we're looking at passive house. The government's concerned that ventilation systems required by Code for Sustainable Homes Level 4, Passive House Standard, mandatory in 2010, could damage the health of residents. That's not me speaking, that is actually a report written last year. The passive house requires an annual heat demand of 15 kilowatt hours per square metre per annum, heating load of 10, air tightness of less than 0.6, and primary energy consumption of less than 120 kilowatt hours per square metre per annum, including all electrical loads. That's the definition. The devil is in the detail. The condition of certification is that a passive house is a building which achieves the thermal comfort ISO 7730 by reheating the fresh air flow rate, which is necessary for adequate air quality, without having to use recirculated air. Now, it's that air quality assumption that I am querying. And I'm querying it on the basis of a project that we built with different ventilation systems and we monitored. Scotland leads the world in asthma. It's a shame, really. It's not a statistic we're proud of. Unfortunately, England is tight on its heels. England, Wales and Scotland are the top three. 1 in 13 adults and 1 in 8 school children suffer from asthma. 37% of 13 to 14-year-olds in Scotland have Ventolin. That's a ridiculous amount. It's a pandemic. This is news coming from the Netherlands, where there's a strong move afoot to ban mechanical ventilation systems completely from Dutch housing because of the systematic failures of its use in house schemes around Holland. There are currently 10 lawsuits in the courts of homeowners who are suing the developers because of poor indoor air quality, inadequate ventilation or overheating. And the study that I've taken this from is indicating the key issues of poor installation, poor commissioning, inadequate cleaning of the filters and systems. Now, again, it's not that in theory it couldn't work, it's that in practice it isn't. So, Bill Bordas, his conclusion for the UK: we need both careful analysis of the design intent and proper understanding of how things actually work in use. We mustn't be doctrinaire, but on the other hand, we may be able to identify safe territory solutions, which one can be pretty sure will work tolerably well, subject to following a few rules. Passive House may be getting to one of these safe territory options with its MVHR, and the option to open windows, brackets, for domestic, at least in its countries of origin. Notice all these caveats, but it doesn't mean it is the only way. And that's his concern, is if we go legislatively along the route of just one solution, then there's an issue, because it means all the others are stultified. Non-domestic, I think, still has a way to go before safe territories can be identified. Right, this is a project we built in order to be able to assess 3 criteria. 4 of the houses had openable windows and were pure natural ventilation. 5 of them were dynamic insulation, and 5 of them were mechanical ventilation heat recovery. And we monitored them for 2 years. We did a research project, first of all, funded actually by the RIBA, to look at what the issues were that we had to tackle and what we had to knock out. And then we proposed the 3 solutions. We designed it to minimize dust mite colonization, reduce off-gassing, and regulate humidity. This is the diagram of the things that we identified as being potential risks, and we wanted to knock out all the potential triggers for people with asthma and allergy. We used the chapters in the book as the prompt for the school that we designed at Carrickle. We wrote the brief, so we're in the beginning, and we're being paid by the client to do 2 years post-occupancy. Now that is joined up thinking. We're being paid. It's not just to do with the defects liability period. We're actively involved in post-occupancy. So, the indoor material specification, we were looking at mass timber. Now, we imported this from Austria. It cost 50,000 kilos of carbon to import it from Austria. But because it's mass timber, it's sequestered 1 million kilos of carbon. What we're trying to do is to set up a Brettstapel industry in Scotland, whereby we can use low-grade timber, connect it with dowels. You can span 18 metres, not a single piece of glue. You just stitch it together with hardwood dowels. It's a beautiful technology, and we're using it again in the house we're building at the moment. These are all buildings built from mass timber. We did a huge amount of modelling with Arabs on the daylighting. We set the brief at 5, and eventually, as a trade-off between the losses and the gains, we settled for 4.5%. And we've achieved that throughout the rooms. It's very satisfactory, and it's very reassuring to know that the modelling has actually happened in real life.